You want to convert? Metric system, we just went over this. Team Duncilis. 1, 2, 3, and 1, 2, 3. You really only need to know this one, K, this is the base unit, that's C, and that's M. Those are the three that you need to know. So 25 centimeters to millimeters. This is centimeters right here, that's milli, it's one step to the right. So take this and move the decimal place one step to the right, that becomes 250 millimeters. 1.58 liters to milliliters. Liters is a base unit. Milliliters is over here. Liters to milliliters. 3 steps to the right. So take this and move it 3 steps to the right. You get 1,580 milliliters. Millimeters to kilometers is going the other direction now. He's starting at milli and going all the way over to kilometers. And so there's 6 steps there. 1, 2, 3, 4, 5, and 6. Bless you. So move it 6 steps to the left. It becomes 0.00? 4301. Yeah, that's right. This would be in kilometers. Or you could write, if you were really crazy, 4.301 times 10 to the negative 3, if you wanted to. That'd be crazy talk, though. Don't do that. Base units are the ones that are here in the middle of the metric system. Kilo, that's not a base unit. Grams, liters, meters, seconds, and moles are the 5 most important ones. So if you wanted to measure your height, which of those would you use? You would use meters, correct? And you can scale it if you want. You want to measure it in centimeters, you can scale it. That's what the centi does. Okay. Amount of water in your tub, you'd use what? Liters. Yep, sorry, this is metric base units. So liters. And if you want to scale that into kiloliters, you certainly could. And then if you want to take the time it takes you to run 300 meters, that would be measured in seconds. That's the base unit. Larissa. Okay, scientific notation and standard notation. When the number is written out in scientific notation, it's a positive number. It means it's bigger than 1. So go to the right and make this number bigger than 1. It ends up being 101,000 if you move it 5 spots to the right. Next, on the number 8, this number is in standard notation. You want to make it in scientific notation. The decimal point's right here. And you got to get the number, move it left until you get the number between 1 and 9.9-ish. So if you do that, it becomes 5.34. And if you get to that number, you've moved it 7 times. So 5.34 times 10 to the 7th would be how you'd express that in scientific notation. Yay. Density is another thing that you need to memorize, at least the equation, which is density equals mass over volume, or the triangle if you want. So if I've got an object 75 grams of mass and it weighs, or it's 55 milliliters of volume, just take 75 grams divided by 55 milliliters. And what do you get? Something smallish? 1.36, and the units there are grams per milliliter, or grams per centimeter cubed. Want to do the same thing with, well, not the same thing actually, use the same equation and solve number 10 for volume. Volume is equal to mass over density. And so you just plug those in. They're both given to you. 77 grams, 2.11 grams per milliliter. The grams cancel out, you're left with milliliters. And the answer is what, 36 point something? 49. Now in this problem, if you put like 0.5, it wouldn't be a big deal. Oh, and the units are for volume are milliliters or centimeters cubed. What's that? How do you do what? Yeah, we're solving for volume. Yeah, and then you rearrange it to solve for volume, so volume is equal to mass over density. This is using the triangle here. Looks like this, density, mass, volume. And so you want to solve for volume, cover it up, and what's left is mass over density, and so that's what the equation is. Density is mass over volume is mass over density, and mass is density times volume because they're next to each other. Alright, for sig figs, if the number is bigger than 1 and it's a decimal, and it has numbers on the right-hand side, then all these numbers count, no matter what they are. So 21 is obviously bigger than 1. All these numbers count. I believe it's 7 significant figures there. The number is bigger than 1 and there's no decimal, then the zeros don't count unless they're smushed in between other numbers. And so these are not smushed, so there's only 3 significant figures there. If the numbers are smaller than 1, and then all the leading up zeros to the first number do not count. And so then all these numbers do count after the 1. And even if there was a 0 there, it would count. So this is 120, or sorry, 0.123, 0.00123, all those numbers count, and ends up being 3 significant figures. If you're going to do math with sig figs, you can certainly do that. And you'll have to do that as well. 3.12 times 21.079. That's what it equals in the calculator, but you can only go to the correct number of significant figures. This one has 3, this one has 5, and so your answer has to be rounded to the 3 sig figs. So 65.7, and then the number after that's a 6, you got to round up, so it ends up being 65.8. You can round up sometimes. For addition and subtraction, it's a little bit different. You just go to the least accurate number, and that's the place that you go. So 2155.2 plus 123.012. And then this one goes out to the 10th place. This one goes out to the 1000th place. So your answer can only go to the 10th place. So 2278.21, and you round that 1 down, so it ends up being 2278.2. On the test, you'll have to graph a graph that looks a lot like this, where you have some mass and some volume. And I wanted to just refresh your memory. I think I used the wrong terminology before. There are 2 types of graphs. I'm not in love with this terminology, but this is the way it's referred to on the test, so I better tell it to you this way. If it's a straight line like this and it's a positive slope, that's called linear on the test, just so you don't get confused. Straight line but a negative slope on the test, that's called inverse or indirect. But this I told you was direct. I'm not in love with the word linear here, because linear, this is linear, and so this is also linear in terms of just the line. It makes a straight line. But anyway, so on the test, a line with a positive slope like this is called linear. So if you graph these points, which I think we can graph, right? These are your y values, these are your x values, just put them on a graph. You're going to have to do that. It's pretty straightforward. And the line looks like this, it's linear. If it looks like this, it's called inverse or indirect. If you want to find density, and you have this information, remember density is mass over volume. So just take these numbers and divide them. And let's say you do this and you get, well, we can just do a couple of them very, very quickly, because I don't expect you to spend a ton of time on this. 32.5 divided by 27, 1.2, and then 58.5 divided by 43 is 1.36, we'll say. So you can estimate that the density is going to be somewhere in there. Okay, somewhere in there you'll find the density. So in that neighborhood. So if one of the choices is 1.3, then pick that choice for your density. That's kind of how that problem looks. If it were me, and it is me right now because I'm the one writing, I'd start with 365.25 days in 1 year. So that's where I would go. 365.25 days in 1 year. And you want to get that down to liters per year. Yeah. And first one will be how many glasses of water do you drink in a day. This is the conversion factor right here. 8 glasses per day. So would go here, 8 glasses per day. Then days would cancel out. Then I know that each glass is 300 milliliters of water. So in 1 glass, 300 milliliters. And the last one's not on here, but maybe you know that there are 1,000 milliliters in 1 liter. Some of you do. Cancel, 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 cancel. All that's left is liters per year. And if you do the math here, thanks, you get 876.6. Right here. 876.6, and this would be, label would be liters per liter, or just liters per, just liters would work fine. That's how I would do it. There's other ways to do it. So no judging either way, but also kind of judging.